questions on Kirchhoff's rules. Look at some of these simple examples and see how you can perform them. Look at this particular circuit segment. Suppose you have a resistor here which is connected to a cell. Let us assume that the cell is 6 volt and the resistance is 2 ohm, and if the current passing is of course in this direction, let us assume that this is 1.5 amp. Let's take these points as A, B. Now we need to work out the potential difference across AB. So potential difference across AB, V is equal to. So you can find out when you look at this in here, if you start from here to here, let's just make the measurement in this direction. Make the measurement of potential difference as shown in the arrow. Across the resistor, the potential drop will be negative because we are taking the measurement in the direction of the current, because the current is in the same direction. So here you will get I times R, so that is minus IR, because this is R and this is I, and so minus IR, and as we cross from here to here, the destination is positive, so that will be positive, plus 6, that will be the potential difference between A and B. So you can write what is the I value. I value is 1.5 minus 1.5 times 2 plus 6. If you work it out, you will get 3 volt. So the potential difference between these 2 points will be 3 volt. This will be at the higher potential and this point will be at a lower potential. B will be at a higher potential. This is the higher potential point and this will be the lower potential point. Take another example in here. In this case, I'll draw another diagram quite similar, but I'm going to change the direction of the current. That's all I'm going to do. I'm going to change the direction of the current in this case. Look at here. You might find it a little bit interesting. It's the same diagram. We just change the values a little bit. It is not important. Here we have the negative. Here we have the. Alright. Okay. Let's put the same values in here. I is equal to. Let's say. Let us assume I is equals to 1.5 amp, and then R is equals to 2 ohm. Let us assume that current is in this direction. This is the current, and this is again 6 volt, and this point, let's take it as P and let's take it as Q. So potential difference across PQ, again you take it from P to Q, PQ. So again we take the potential measurements in the same direction. So since across the resistor, when you work out the potential difference, it will turn positive. Why? Because we are taking it opposite to the direction of the current. So you can just write the potential difference V in this case as I R, and here this is the destination point which is positive, so that will again be positive. So that is equals to 1.5 times 2 plus 6. So this 3 plus 6, that would give you 9 volt. So you understand the trick, how to find out the potential difference between different points. Let's do a little bit more complicated question. It looks complicated, but pretty simple. We will have a circuit with several resistors. Okay, I'm going to draw it. So I can add a couple of cells in here and then let us have a resistance in here. I can add many things. Doesn't really matter. This is not a real circuit. As we implement it, it's just something. Let's have one cell here. All right, and another resistance here. Okay, we can have a resistance here. All right, connect them together here. Okay, here we will have a resistance. Okay. This is just a random circuit I have drawn. Put as a question number 3. Okay, let's call this point A, B, C, D, E, and F. Assume that this is 6 volt, this is 5 volt, and this resistance 2 ohm, this resistance 3 ohm, this is 1 ohm, this is 2 ohm, and this is 3 ohm. Now, the question something like that, find the, of course, before that we need to specify the current. Let's assume that the current here in this direction, doesn't really matter, we are just doing an arbitrary question. This is 1 amp, and current here, I take it as 1.5 amp, and this resistor, let's take it as 2 ohm, and the current in here, probably in this direction, this is 1 amp. Okay, find the potential difference between A and F. So you need to start from A and you need to reach F. Now you don't need to worry about the rest of the circuit structure. You just need to find out a path to reach from A to F. So you will take this path A, B, E, F. So you will be able to reach from A to F. We will just take the measurement of potentials across each of these segments. From here to here, this is 2, it's in the direction of the current. So this is minus 2 times 1, minus 2 times 1. Here it is, this is positive, destination is positive, so it will be plus 6. Then from here to here, it's in the direction of the current, so it will be again negative, so minus 2 times 1.5. Then from here to here it is negative because the destination point is negative, so minus 5. And here it is 1 times 1, this is positive, so that will be plus 1 times 1. So this will be the potential difference, so we can work it out. Minus 2 times 1 is minus 2 plus 6 minus 3 minus 5 plus 1. So minus 2 plus 6 is 4, minus 2 plus 6 is 4, minus 3 is 1, minus 5 is minus 4, minus 4 plus 1, that is equal to minus 3 volts. So this will be minus 3 volts. So you are taking the measurement from here to here, and you should realize this point is because you get negative, it means that compared to this negative sign here implies that compared to A, F is at a lower potential. What does it mean? F is at a, that F is at a lower potential than A. That is the meaning of the negative sign. Just remember why we get a negative sign when we work out the whole thing. It's only because with this technique, if you get a negative sign, it means that the destination point is at a lower potential compared to the starting point. So it's a pretty easy way to work out some of those questions, and regularly you will get such simple questions for different kinds of competitive exams. Thank you very much for the time being, and till we meet again, goodbye.